So bam, we're recording. And I'll post it on a link right below the link where you join the classes. Give me a moment to admit a couple more here. And just in case you should miss class, although I don't encourage that due to technical difficulties, whatever, and I'm only going to keep it on there for that particular day. So the next time, the next Monday we come to class, that link will be off, just so you know. All the time, I'm constantly updating things I need to communicate to you on the Canvas page. So please, before you get started on this week's quiz, if you could just watch these two videos quickly. They're less than 3 minutes on how I want you to submit your quizzes, because there's 103 of you. Can you imagine 103 emails? Oh my word. So there's going to be an email, it looks like this, and you're going to submit your quiz in this particular email to me. So if you forget and you submit it in Canvas, or you just submit it in a separate email, I'll just kindly remind you, would you please not do that again and go find the email that you need to submit the quiz. So please watch those videos. There's just a correction on the paper copy problem number 6. You can't see the x-intercepts, so there it is, but it is on the video, and I need to get going today, so please watch those. There's new stuff all the time. Another thing I'm going to forget to say, but I'll end up posting it before you start on your quizzes, is that the spiral questions are optional now. But I encourage you to do them, because it should be an easy A. It's like a separate quiz grade, and it's only a couple problems. So these problems, I'm going to do practice quiz 2, which is not on any of the videos. Practice quizzes 1 and 3 are, but usually a couple of problems at the end. If I don't have time to go through them, watch the video. They're really pretty easy compared to the other problems. I encourage you to do them. Again, it should be an easy A. And it's also easy to retake this section of the quiz. So a lot of encouragement on those. I just don't know that I'll have time today to go through them, because I want to try to get through a practice quiz. So pay attention to these numbers up here. That tells you what practice you're on, and I'll try my best to get through this with our 20 minutes. And remember, anytime you can shoot me an email and ask questions, so on and so forth. Okay, so we have this big long polynomial, and we want to know all the zeros and then the multiplicities, which are the exponents of those zeros. So it's the exponents on the factors. So what I do is just right above here, I generally do this. I write in the factors, and I really should be writing the exponents in there too. So we have an x plus 3 to the first, we have an x plus 1 squared, and then a 2x plus 3 squared. So that's probably the best thing to do, is just write all those factors left to right. The -4 is a common factor. You can just leave that alone. So if x is a factor, then zero is the 0. Okay, so I'll go left to right and do all the zeros. If x minus 1 is a factor, the 0 is 1. So it's like setting it equal to 0. If x plus 3 is the factor, then -3. If x plus 1, then -1 is the 0. If 2x plus 3 is the factor, then -3/2. So again, what you're doing is you're just taking them equal to 0, solving it out. Should be something almost mentally that you can do. Oops, a little bit off the screen there. Then next, you want to know what the power is on those factors. So 2, 2, 1, 2, and 2. And I think on the answer key, I didn't go left to right, but it doesn't matter. Just get them in there, and that's all I want to know. So again, multiplicities are the powers on the factors. And then the relationship between the factors and the zeros is something that we've done a lot of in the first trimester. All right, problem 2, what is the leading coefficient? You are welcome to go into Wolfram Alpha and just type this monstrous beast in there. That's fine. There's a simpler way to do it. So that simpler way, I can probably not even use the calculator here, is to take the -4 right here. And then what we're going to do is we're going to multiply by the coefficient on x each time, but raise it to this outside power, because if we're considering x minus 1, it's squared. So it happens twice, and we have to do 1 times 1. So over on the right here, I will put all of these, so times 1 right here for the x plus 3 times 1 squared. So if it was some other number, so this 1 here in front of the x squared times 2 squared on the end. So if it was some other number besides 1 in front of these x's, that's what would go in your parentheses there. And then you just simply crunch all that out. And so if we were expanding this all out, those would be the leading terms, x to some power, 2, 4, 5, 7, 9. It'd be x to the 9th, actually. But we just want the leading coefficients. So you just take all of those coefficients of x to the powers, and then work this through. So this is -4, a bunch of 1s in here, times 4. So that's -16. Again, you can go to Wolfram Alpha, type this in, and this is type expand before the that long, and it will expand it out, and you'll see the first term as -16 x to the 9th, and then just take the -16. All right, problem 3. So we're getting to the heart of the matter here. So standard form equation, and I'm actually going to go to Wolfram Alpha. I will let you use this because it's not part of the standards to expand things out. So I don't care if you just go do that. We've got enough to do as it is. So you can go do this. So we're doing squared and then times x plus 2. And this will expand it out. So 2x to the 4th, you want to look on the result here, minus 8x to the 3rd. And I'll go back now to my overhead here. So 2x to the 4th minus 8x to the 3rd minus 6x squared plus 36x. So it's good to know the expanded form because it helps us answer a lot of things that we're going to need to answer down here, like the y-intercept, which would be 0 because that's the number added on the end. The degree is 4, the leading coefficient is 2. So we are an even positive. So we then take out our trusty little guy here and look up even positive. Both end behaviors are positive infinities. Okay, so from there now we fill our little table in. So how does this work? Well, ignore the common factor in front and then just list all of these factors with their powers. I didn't put the power last time, but now I'm going to. Okay, so if the factor is x, the 0 is 0. Multiplicity is 1. What's the multiplicity? That's the power on the factor. So these powers here are the multiplicities. And then that's going to help us sketch this. So you should plot out the x and y intercepts first. So you have a y-intercept of 0, an x-intercept of 0, they're really the same thing, an x-intercept of 3, and an x-intercept of -2. The next thing you should do is you should go to a graphing calculator, Okay, and the one that I showed you online here is not that one. It is, okay, come on here. Don't freeze up on me using my lesser of two good computers. So go in and graph this and take a look at it. You're definitely going to want to do that before you do any graphs. And I am only going to do this once because of the time. Then you need an enter. Oops. Okay. What did I do there? Why is it? Shouldn't be doing that to me. I have to use another x plus 3 squared times x plus 2. Huh. I don't know why it's doing that to me. It shouldn't be. All right. One more time here. Let's see if it does. Oh, there it goes. Okay. And let's just zoom out a little bit. So you see this, it's got rather a deep minimum, but this will just give you an idea of how it should look when you go back to graph it. And so you have this deep, it's coming through here, this deep minimum, but we're not overly concerned with exactly where. What we're concerned with, okay, is at these points. So at 3, we have at 2. So it's going to bounce. It's going to bounce back, and then it's going to cut through at -2 and at 0 because those have multiplicities of 1. But just use that to get an idea. Okay, and so you see, there's no way. So the peak is right there is at 24, and there's no way we're going to accurately be. And then this one down here is at -32. That we're totally going to graph these 100%. So what I'm looking for is that at these x-intercepts that you're representing the graph correctly there, and then in your classes that are above this one, you'll learn how to find those exact points. All right, so moving a little bit quicker here because, oh my gosh, I got 7 minutes. All right, so you can go expand this out, although I put a line there so you don't need to, but you'll find that the degree is 5 and the leading coefficient is 1, so it's going to be an odd positive. The y-intercept is going to be 16. And so looking up the odd positive, this is going to be -infinity and positive infinity as you look this up here. So 0, so we want to take your factors with their powers down below here, x minus 2, x minus 1. So the zeros will be -2, 2, and 1, multiplicity of 3, 1, and 1. Now we have not had a multiplicity of 3 yet. Which is interesting. So we're going to come down here and plot our zeros at these 3 places. And then you're going to get take a look at the graph to get an idea. So a multiplicity of 3, I drew this out on Thursday. It's going to cut through pretty flat. So as you come up here, try to be a little bit flatter as you cut through this. And then it's going to come up to 16, and then it's going to come down, cut straight through 1 because it's at a multiplicity of 1, and then turn right back around and come up. So again, we don't know for sure where it turns around, okay, but we know through -2, because of the multiplicity of 3 now, it cuts through, but it cuts through flat. And then these other 2, it's going to cut straight through, because of the multiplicity of 1. And then if there's a multiplicity of 2, it's a bounce. Okay, and that's what all of this is here. And we're really not going to go beyond 1, 2, or 3 multiplicities. So I'll stick to talking about those. All right, 5 minutes. Can I do it? Problem 5. Notice this. So what do? You've got to get the zeros. Okay, and you're going to go to the math portal, which I'm not going to do, and it's going to give you this. 3 2s. That means that 2 is a triple root, and it's going to be a multiplicity when you write the factor of 3. So it's like saying x minus 2 times x minus 2 times x minus 2. This is very closely linked to factoring that we did the first try. Very, very closely linked. Okay, so here we have degree of 3, leading coefficient of 1. Look at this leading term, and that is an odd positive. Y-intercept's -8, so it's this in the standard form, the number added on the end. And looking this up here, okay, odd positive is right here, -infinity, +infinity. I'm going fast here because I have very little time. And then this is what you would have here. So 2 and 3. So this one's a pretty easy sketch. It's going to cut through -8 down here, the y-intercept. And it's going to get flat going through here because it's a multiplicity of 3 again. Oh, whoops, I'm off the screen. Okay, so anytime you have a multiplicity of 3, it gets flat as it cuts through. But anyway, what's new on this is you have to take this into Math Portal, type it in to get the roots. You'll get 3 2s. So that means you have x minus 2 times x minus 2 times x minus 2. And that's what you need to do there. And I think there's one on the quiz where you have to do that just like that. All right, 3 minutes left. I'm going to get problem 6 done. 7 and 8 are for you to explore. They're definitely not hard to do. You can explore them in the video. So -2, 1, and 3, you're going to write them right here. And it looks like the way that the graph cuts through, that they're all a multiplicity of 1. So we can write the factors. So there's no bounces and there's no flat cutting through. So these all have to be a multiplicity of 1. So that literally is what you put up here. Once you figure that table out, you have the factored form. Then what can you do? Take that in to Wolfram Alpha, expand it out. Again, I've got 2 minutes left. Minus 2x squared minus 5x plus 6. Degree is 3, leading coefficient is 1, so we have an odd positive. Y-intercept is 6, don't forget that's the number on the end. And then looking up, so you're always going to use this when you look up the left and right end behavior. All right, so it's 8:19. That's the first 6. I encourage you to look at these and do them. They're not hard to do, but you might need a little help with the explanation of them, but it is like a separate quiz grade, but it is going to be optional. All right, I'm going to end, and we will see you all Thursday. Do your quiz, submit it to me in the way that I showed you, and all will be good. And you can always email me and ask a question if you need to.